Today we are going to learn to measure a flow through rate venturimeter, how the water is flowing. Okay, so this is a venturimeter. So this is the inlet and this is the throat. So what is meant by throat and what is meant by inlet? What is meant by venturimeter? So I will show you the diagram. So variable area. So this is the inlet. Suppose this is section 1-1 and this is called throat where the area is minimum. This is called section 2. Okay, in our experiment the water is flowing. So here water is flowing and that's why we are calling this as inlet. So manometer is fixed at the inlet. So manometer is fixed at the inlet and at the throat. This manometer consists of manometric fluid as a mercury. So here the height is high, so I will tell you why this is. So if you make a horizontal line and this is A and this is B, suppose this height is h of hg, suppose this is a pressure P1 at this point and at this point P2, because section 1-1. At section 1-1 the area is A1, diameter is D1. At here the area is A2, diameter is D2. Okay, section 2. Now, what is venturimeter? The area is decreasing. So this part is called convergent part and this part is called divergent part. So convergent length and divergent length is same, then it is called venturimeter. Otherwise, else if this length, convergent length and divergent length is different, depends on application, then it is called CD nozzle, convergent divergent nozzle. Okay, so here this diameter is bigger, this diameter is less, so diameter is continuously increasing. At inlet it is maximum, so at inlet the pressure energy is maximum, at inlet pressure energy is maximum and kinetic energy is minimum. This is max and this is minimum. So here at the throat the pressure energy drops, pressure energy is minimum and kinetic energy is maximum. So use of nozzle, use of divergent section, convergent section is to increase the velocity. So here the pressure is more because the area is big, the pressure is more, P1 is more, so it pushes the mercury up right here. So because of this high pressure, P1 is high. You understand? So pressure energy is going to convert it into kinetic energy. Now, last week we derived the equation that is P1 minus P2, higher pressure minus lower pressure over rho Z is equal to rho of Hg over rho of water, I will say fluid, what is fluid, minus 1 into H of Hg, and this is nothing but the pressure head, HW of fluid, HW of fluid, sorry, H of fluid is equal to rho Hg divided by rho F minus 1 H of Hg. So for our YouTube manometer, for our experiment, the water is flowing, that's why it is HW is equal to, the mercury is 13,600, density of water is rho W minus 1 over Hg, and for that we got 12.6 H of Hg. Okay, So we know the water head. Now, if you apply the Bernoulli's equation, what is Bernoulli's equation? Energy at inlet is equal to energy at outlet. So your outlet may be throat or maybe outlet. Okay, so you can choose. So energy at inlet, which type of energies are there? Potential energy, kinetic energy, and pressure energy. Heat and work. But this is not a heat and this is not a work producing device. So energy at inlet is equal to energy at throat, and that is nothing but pressure at inlet over rho g plus kinetic energy V1 square over 2g plus potential energy Z1 is equal to P2 over rho g plus V2 square over 2g plus Z2. So as the height of inlet and outlet is same, so Z1 get cancelled with Z2. Okay, and here if you take P1 is higher, P2 is lower, so I will write P1 minus P2 over 2g. Sorry, rho g is equal to V2 square minus V1 square over 2g. Okay, P1 higher, V2 higher. Pressure energy is converted into kinetic energy. Okay, so this equation. Now, as per continuity equation, you know continuity equation. What is continuity equation?
Qn equal Q.
Mass neither be created nor be destroyed. Okay, so flow rate at inlet is equal to flow rate at outlet. So that is, what is flow rate? A1V1 velocity is equal to A2V2. So we know area, we know diameter, we know, so we can put this V1 or V2 here and we can find out the Q. So that Q is given, so I'm not going to derive the equation. Okay, so we'll directly write the equation. So Q theoretical, this is called theoretical because we are using formula, basic formulas. So Q theoretical is equal to A1 A2 under root 2G H F. F means water. Okay, HF divided by A1 square minus A2 square. 2GHF A1 minus A2 square. Okay, so this is the formula. Now here area is known, A2 is known, 2GHF, HF we already calculated here, HW. Area is given to you. So area of the at inlet diameter is given. We can find out area. The diameter is given at throat. We can find out area. So Q we can calculate. So our objective is to compare actual theoretical flow rate. So this is theoretical flow rate. What is actual flow rate? Actual flow rate. So that we are going to measure here. So what is the procedure for experiment? Okay. Start the pump. Okay, I will start the pump. Open this wall together. Now, anyone you can open here. So I open this, so water is coming from this and this, and here it is flowing through Venturi. So this is inlet, this is throat, this is outlet. Okay, so we connected manometer here. This manometer, water is flowing through this pipe, and coming here, and it is going, and the pressure is acting. So this pressure is less, this pressure is more. Means this is a connected at inlet. Okay, so this is, you can see this is connected, this is connected, this is connected to inlet. So this is connected to inlet. So this is connected to inlet. So here the pressure is more, here the pressure is less. That's why height is there. Okay, now we need to see the ear. Is there any ear inside? So check these pipes and check the ear like this. If there is a ear, it will come up. So goes down, it will come here. So keep this open. I found here ear. Okay. So there also, if I close it, the level is same. You can see the mercury level is same. Okay. So in exam I found this. Teacher, it is same. How come? So sometimes you didn't open this wall, you didn't open this wall, you didn't open this wall, or this is closed. If it is closed, how the water will come? The same water is applying force, same level. Okay? So this should be along the pipe direction, along the flow direction. Okay? Then you can find here deflection. You can find the difference. Okay? So, second, remove the ear from here. So keep it water going outside. Check the ear from that side if there is a ear. So if you found ear here, operate this. Operate simultaneously. Or operate this. So you have to remove the ear. Now if you see the water is continuously coming, there is no discontinued flow, then we can say there is no ear. Okay? Now I will close it. Okay? Now we close this, and this is now. So we'll record this reading H1 and H2. We'll record the water in this tank for 10 liter. So this wall, you can see this wall. We can close this wall by the ball, and we can measure the time from 0 to 10. So to collect 10 liter water, measure the time. So when the water reaches above 10, remove this immediately. Okay? Now this is the experiment. This is the experiment. Now how I can write the observation table and calculation table. Okay? So what I observed and what is now observation table. Observation table. So make a row. Obviously the first column will be a serial number. Serial number. Second column I will write volume. Unit capital V in liter. Don't forget to write the unit. Liter. Okay, then I'm going to measure the time, t second. Okay, now what I am measuring? H1 and H2. What is this? A manometer reading. Manometric readings. Manometric readings. So first I am going to find H1 in millimeter. H2 in millimeter.
Difference.
And difference is small h of Hg is equal to H1 minus H2 in millimeter. Okay, so I will record this. So I will record the 4 readings. So first is 1, 2, 3, 4 for 10 liter of water. We'll measure the time and we'll write. Okay, now after that, how we can do the calculation? Calculation table. Calculation table. Same make a row. Obviously, first is serial number. First column is serial number. Second. Now what we need? HW. Okay. So this is my procedure. So I need HW. So I will write head of water, HW is equal to 12.6 H of Hg in meters of water. Okay. Then I need Q theoretical or Q actual. So Q actual, I will write Q actual. So what is Q actual? Can you tell me? Meter cube per second. What is Q actual? Volume over time. So Q actual is equal to volume over time. volume over time. It is in meter cube per second. Okay. Now what I will find? I will find Q theoretical by this formula. Q theoretical. This is also meter cube per second by using this formula. Then what is asked? What is my objective? I'm not memorizing the table. Okay. What is our aim and what is our procedure and what is our objective? So from objective it is asked to find out coefficient of discharge. So CD. It is denoted by CD. So coefficient of discharge is defined as Q actual over Q theoretical. Now why teacher Q actual over Q theoretical? Why? Why not Q actual, Q theoretical over Q actual? Tell me, actual is more or theoretical is more? Actual is more?
No,
Theoretical is more because we are not considering friction losses. And in actual, depends on material, there is a friction. And there is a losses. And that is losses are encountered or calculated by coefficient of discharge, CD. Coefficient of discharge is always less than 1. It varies from, it is a fraction, varies from 0 to 1, not 1. Okay, so 1 means ideal condition. Okay, so this we can calculate. So we'll record the readings. First readings we will record. So can you write there? So come H1. Get it back. So record the H1. So H1 is higher and it is 410. So write 410. Okay. H2 is 334. 334. 334. 334. Now H1, H2 done. Now bring the stopwatch. First cupboard. Cupboard. Here. First one. First. Yes, open this. Check working or not. So I will close this tank wall. Okay, sit down. So this is start, this is stop and reset. So at 0 I will start and at 10 I will stop. .65 immediately open this wall. Immediately open this wall. Otherwise motor will run without water. It will become hot. Okay. Now center but this first is for reset. Okay. Now second readings. Look at this scale and close the wall. Look at this scale and close the wall little. Close the wall little. How much little? So there is a deflection, there is a change in the height. Yes, there is a little change. Okay. Now I will record H1, H2 for time for 10 liter and I will record. So goes on continue for 3-4 readings and at last close this wall together and stop the machine. So close this wall together. And stop the machine. Pump.
That's one thing.
It doesn't matter. It is inlet and outlet is closed. Okay. We can close it also to not allow the air. Okay. So this is the end of the experiment. Now we'll repeat this experiment. You individually come and do the experiment. Okay. Thank you very much.